Hello, Algebra 2 students. This is a lecture on 4.6, which is called Performing Operations with Complex Numbers. And in reality, this is the moment we've been waiting for our entire lives. This is the introduction to the imaginary numbers. Imaginary and complex are kind of used interchangeably to describe this type of number. And really just an exciting moment. I'm sure you guys are all thrilled for this lecture. In order to understand this, we're going to need a couple of background information just to review a couple things really quickly from recent studies. In the last lecture in 4.5, we talked about how to solve equations like this. Step 1 said to get the thing that's being squared by itself, which it is in this problem. X is being squared, it's by itself. The way to get rid of something being squared is to take the square root of it. Squaring and square root are inverses of each other. They cancel each other out, so we'd just be left with x. Also remember that when you take the square root of both sides, that creates a plus or minus, so we have plus or minus the square root of 32. Now, this is not simplified. There were 3 steps to make sure a root is simplified, and one of the things I told you is the number cannot have any perfect square factors. The number under the root cannot have any perfect square factors. And 32 does have a perfect square factor. It's got a couple of them, actually. The biggest one, remember, the perfect squares are things like 1, 4, 9, 16, etc. 16 is a perfect square factor of 32. So I could change this to say the square root of 16 and the square root of 2. The reason I chose 16 because it's on that list of perfect squares, and 16 times 2 is 32. We can simplify the square root of 16 to 4. So our answer to this question would be x is equal to plus or minus 4 root 2. It's going to be really crucial that we know how to do this as we look into the second part of this lecture. But that's a little bit of review. Similarly, I want to remind us of a problem like this. We would do the same thing. We would take the square root of both sides. However, it's been true for your entire math career so far that you're not allowed to take the square root of negative numbers. And if you took a second here to type in the square root of negative 32 into your calculator, it will say some sort of error, okay? Because we're not, at least have not, been able to take the square root of negative numbers. The reason for that, I'm not going to use the number 16. I'm going to use like x squared is equal to negative 4, okay? There is no number that when multiplied by itself, it equals negative 4. At least no number that you know of yet. The things that would get us close are 2 and negative 2. 2 times 2 is positive 4, right? And I want to get negative 4. What number times itself is negative 4? 2 times 2 gets us to 4, not negative 4. What about negative 2 times negative 2? That also doesn't get us to negative 4, because negative 2 times negative 2 is still positive 4. And so we would historically look at this and say, no solution. No, that's supposed to be no solution or something along those lines. Today, we are learning that, hey, this does have a solution. It's not exactly a real number. It's an imaginary number, but it does have a solution nonetheless. And then the last thing that I want to talk to you guys about, this is still review, that when we have a root in our denominator like this is a binomial with a root in our denominator. The way that we fix this is we actually multiplied by 1, but it didn't look like 1. If you remember, it was the conjugate of the denominator. And conjugate simply means switch the sign in the middle. So instead of 5 minus root 3, the conjugate of 5 minus root 3 is 5 plus root 3. And then you should all agree with me that by multiplying by this, we're not changing the value of the number because we're just multiplying by 1. So in order to simplify this now, we'd have to distribute the 2. 2 times 5 is just 10. And 2 times root 3 would just be 2 root 3. Because one isn't in a root and the other one is, we just write them next to each other. And then our denominator, we would actually have to FOIL this. 5 times 5 is 25. And then we would do 5 times positive root 3, which would give us 5 root 3. And then this one would be 5 times negative root 3. So then positive times a negative makes it negative. And then once again, we just write them together because one's in a root and one's not. And then we know that root 3 times root 3, if you have a root times itself, it just gets rid of the root, so it would just be 3. And it'll actually be minus 3 because it's, again, a negative times a positive. Our numerator would still be 10 plus 2 root 3. These are not like, they cannot be combined. But my denominator, the 5 root 3 and the negative root 3 cancel, and we are left with 22. I would accept this as a final answer to this question, and the skills that we use to answer this question are going to be used in 4.6 as well. All right, so what's driving this topic? This is the concept of the number I. I is not going to be a variable that you've solved for. I means something, but oftentimes we treat it like it's a variable. So what is I? It is an imaginary number used to create an entire new system of numbers called the imaginary numbers or the complex numbers. Here's what we know about I. I is equal to the square root of negative 1. Historically, if I asked what is the square root of negative 1, you would tell me it doesn't exist. You can't do it. You type it into your calculator, you get an error. But I'm going to tell you now, from now on, when you see the square root of negative 1, you're going to replace that with the letter I. You also need to know that I squared is equal to negative 1. And this should kind of make sense as it's a direct result of this if you were to square both sides. I squared is equal to, remember, the square root and the square cancel each other out, and you would just get negative 1. So you need to know that I is equal to the square root of negative 1 and that I squared is equal to negative 1. In the previous slide, I asked you, what is the square root of negative 32? And we would have said no solution. However, anytime you have a square root of a negative number, what you're going to do is you are going to simplify it like you would have the square root of 32, right? We broke this data into, if it was the square root of 32, we broke it into root 16 and root 2. But because this one is negative, we're also going to break it into a root negative 1. You guys should still recognize that these three things, when multiplied together, do equal negative 32. So it is a legal move. And then we know the square root of 16 is 4. The square root of 2 can't be simplified. And the square root of negative 1, right here, is I. So 4 times root 2 times I. Now, I'm just going to tell you this. We don't like to write I at the end, or at least we don't like to write it after roots. So whenever you see this, because we don't know where this root ends a lot of times, especially when we're doing math and we're kind of sloppy. So we write the I in front. 4I root 2 is how you would simplify the square root of negative 32. So the answer to this question here was no solution, but now it would be plus or minus 4I root 2. Interestingly enough, that does answer the question, what squared is negative 32? Right? The whole point is we're looking for something that when you square it, you get negative 32 out. Let's try this. What is 4I root 2 times 4I root 2? In order for this to actually work, it better equal negative 32. Because this is all multiplication, we can just do it in any order that we want to. We can pick 4 times 4 and multiply those, and that would be 16. And we could do I times I, that would be I squared. And we also know that root 2 times root 2, right? If you have the same number being multiplied with a root, you just get rid of the root. So it would just be 2. 16 times 2 would give us the 32I squared. And what is I squared? Well, we know that I squared is negative 1, giving us negative 32. That's pretty cool, I think. What number, when we square it, do we get negative 32? Well, 4I root 2, right? We squared it, we multiplied it by itself, and we did end up with negative 32. Let's take a step back, though. What is an imaginary number? Imaginary numbers are going to be written like this, a plus bi. where b can't equal 0. So it'll be something like 2 plus 3i. This is considered an imaginary number. We would have combined them, but we can't because one has an I and one doesn't. So this is considered one imaginary number. It's got kind of an imaginary part and a real part, but combined, we call this an imaginary number. We can also have just an imaginary number. It could be like negative 3i. Okay, the a term can be 0, but the b term can't be 0 in order for this to be an imaginary or a complex number. The title of this section, Performing Operations with Complex Numbers, the operations that we're looking to do is to add, subtract, multiply, and divide these complex numbers. So how are we going to do that? I don't actually think this is that helpful. This is from the textbook. Adding and subtracting is fairly simple. If we just talk about it, a plus bi, this is an imaginary number, and we're going to add a different imaginary number, c plus di. How are you going to do that? Well, you're going to take the things that don't have i's with them and add them. And then you would take the things that do have I with them, bi and di, and add the coefficients, and they'll have an I at the end. Same idea with subtraction. You're going to take the things that don't have i's and subtract them, and then the things that do have i's are going to be subtracted. So let's take a look at an example here. This is an imaginary number, 8 minus I, and this is a different imaginary number, 5 plus 4i, and we want to add them. All you do is you take the things that don't have I and add those together, 13, and then you would take the things that do have i's with them. Negative I plus 4i, negative I plus 4i would be plus 3i. You're essentially treating I like a variable, like x. We know that I represents something. We know that I represents the square root of negative 1. But how we treat it, how it behaves, most of the time is going to be like a variable. You guys try this one. We should be really good at this kind of naturally because we're used to adding numbers, obviously. Those two would combine to make 9. And these two would combine 2i, and a negative 5i would combine to make negative 3i. So we're also going to be subtracting complex numbers, right? That was the addition. Now we're going to subtract them. I'm actually going to start with this one. To subtract an imaginary number, imaginary number subtract a different imaginary number, you're just going to subtract the parts that don't have i's with them. 3 minus 1 is just 2. And then over here, we would have 2i subtract a 5i. A lot of times people are just going to write 7i because they're used to adding, but this is 2i subtract a 5i, giving you negative minus 3i. So this imaginary number, when you took this one and you subtracted this one, you would get 2 minus 3i. Sometimes the imaginary numbers are going to look like this. You're going to just follow your concepts that you would have if I was a variable like x. If you were to simplify this, you would distribute that negative sign. You would get 10 minus 6 minus 7i plus 4i. Combine the like ones, 4, and these ones would combine to make negative 3i. 4 minus 3i, that would be your answer. As for multiplying complex numbers, this still isn't too bad. I will tell you, dividing them is pretty rough, but multiplying them isn't bad either. Your first step would be to distribute that 4i. These are going to behave just like you would expect if it was a variable, with one exception. You would do 4i times negative 6, that would be negative 24i. And then 4i times I, that would be plus 4i squared. Now this doesn't look like an imaginary number. Remember what I told you about imaginary numbers? They need to look like a plus bi. This one's got an I squared. If you recall, I told you guys that I squared is equal to negative 1. We shouldn't be ending with I squareds in our answer. We should be changing I squareds into negative 1. So this isn't plus 4i squared anymore. It would actually be just minus I, negative 24i minus 4. Because I squared is negative 1, and 4 times negative 1 is negative 4. Now, this is not quite a final answer. I want the imaginary part at the end and the part that doesn't have an I in front. So this one would actually be negative 4 minus 24i. Final answer. Very similar here. I would encourage you to pause it and try this. This is going to be a problem where you have to FOIL it, combine your like terms, and remember that I squared is equal to negative 1. Let's go ahead and try. 9 times negative 4 would be negative 36, and 9 times 7i would be plus 63i. Then you're going to do inside times inside. That would give you plus 8i. And then negative 2i times positive 7i would be minus 14i squared. Combining some like terms, we got some like terms right here. That would be 71i. This negative 36 plus 71i. This negative 14i squared. Remember, I squared is equal to negative 1. So this just turns into plus 14. Right? Because negative 14 times negative 1 would be plus 14. Negative 22 plus 71i would be our final answer. The last thing that we need to talk about for this part of the lecture is dividing a complex number by another complex number. Right? We did the addition, subtraction, and multiplication. Now it comes to the division. And the division is going to be the most challenging, but if you recall that conjugate business from the first slide of this presentation, it won't be too bad. What you're going to do is you're going to identify the conjugate of the denominator. If I have 1 plus I, the conjugate of 1 plus I would be 1 minus I. Remember, conjugate means switch the sign in the middle. We want to multiply by the number 1, but have it be the conjugate of the denominator. Remember, if you divide something by itself, it's only the number 1. So we're not changing the value of the number when we do this multiplication, but it is going to change how it looks. Just like we had to do in the last slide, we're going to need to multiply 5i times both of these. 5i times 1 would be 5i, and 5i times negative I would be minus 5i squared. As for the denominator, we are going to have to FOIL this. 1 times 1 is just 1. 1 times negative I would just be minus I. 1 times positive I would just be plus I. And then I times negative I would be minus I squared. There should be some good cancellation that happens here. The O and the I from the FOILing cancel. And also remember that I squared is actually negative 1. So in my numerator, I have 5i minus 5 times negative 1. And in my denominator, I have 1 minus negative 1. Rearranging this, this would be negative 5 times negative 1 would be plus 5. So we'd have 5i plus 5 over 2. We want the number without an I in front. So it looks like 5 plus 5i over 2. And actually, I don't even love this answer. Because remember what I told you about imaginary numbers. They're written like a plus bi. So just divide both by 2. This would be 5 halves plus 5 halves I. Final answer. I know that's quite a bit. Let's try another one, make sure it sinks in. And then that'll be it for part A of 4.6. Our denominator, the thing we are dividing by here, is 1 minus 4i. So the thing that we're going to multiply by would be 1 plus 4i over 1 plus 4i. This is going to need a FOIL in the numerator and a FOIL in the denominator. 7 plus 7 times 1 is 7. 7 times 4i would be 28i. And 5i times 1 would just be 5i. Last times last would be 20i squared, right? Because 5i times 4i would be 20i squared. Let's do the same thing with the denominator. Because these are conjugates of one another, they should be canceling. 1 times 1 is 1, and 1 times 4i would be plus 4i. 1 times negative 4i would be minus 4i. And then last times last would be minus 16i squared. We do get that cancellation. As I had promised in our denominator, we have a 4i and a negative 4i, meaning our denominator is now 1, and I squared is negative 1. So this actually ends up being plus 16. As for our numerator, we have 7, and then plus 33i. And then this plus 20i squared is actually negative 1, so this would be minus 20. We can do a little simplification here, negative 13 plus 33i over 17. And remember, we want our imaginary numbers to be written like that. So our answer here would be negative 13 over 17 plus 33 over 17i. That's our answer for that division problem. So this is part A of 4.6. We're going to actually solve equations in part B. Please reach out to me with any questions, and good luck.